Hello everyone, welcome to my channel Physics Tricks. So in this video we will be solving 10 questions based on the potential difference and the current in the circuit. Okay, so if you solve these 10 questions thoroughly by understanding each and every concept in the question, I'll assure you that you will not find any difficulty in finding the potential difference and current in the electrical circuit. So see here, this is the first question, and yes, I'll assume that you know Ohm's law, right? You know Kirchhoff's current law, Kirchhoff's voltage law thoroughly, right? You don't have any like difficulty in these three theorems and laws right now. So see here, and the first question it is given, in the circuit shown the current in 3 ohm resistance is. So we have to find what is the current flowing through this 3 ohm resistance. Okay, so one more thing, this symbol is nothing but ground. This symbol is nothing but ground, and ground potential we generally consider at 0 volt. So over here also 0 volt we have, and over here also 0 volt we have. Now once we know this is 0 volt, what is this potential? So whenever we have what is called as the circuit like this is the positive terminal, this is the negative terminal, and this is what is called as supposed to be x volt. Okay, now if I consider one point potential as 0 volt, right, that is my choice, right? A point potential I considered 0 volt. So what is the potential at this point? What is the potential at this point? This potential we have is we can say 0 minus x, and that will be minus x volt. Okay, now why? Because potential difference across this battery will remain same, but the potential may vary. Now to understand this, I'll take very simple example, and that is, if I have a mobile phone, this is the mobile phone, right, and if I wanted to move this mobile phone from one point to other point, right, I have to do some work on it, right? So this is the point A, this is the point B, right? That work is stored in the form of potential energy over here. Right now that work is stored in the form of potential energy over here. So now if I consider potential energy at this point as 0, then only we can say at h height the potential energy is mgh. If I consider potential energy at this point as mgh, the h height, the potential energy will be 2 mgh, but the difference will remain same, isn't it? That means potential energy is a free choice for us. We can define the potential energy on the reference line as 0, and accordingly we can say that potential energy at height h is mgh. So over here also the first potential is our choice, so it is free. You can consider here 10 volt, you can consider here 20 volt or whatever, but this point potential will be different according to your choice. Okay, now so this 20, if you consider this as 20, then 20 minus x is the potential at this point, that is B point, we can say right now. So potential difference, right, that VB minus VA must be equal to VB minus VA must be equal to, we have minus x volt, or else VA minus VB must be equal to x volt, right? Higher point potential minus the lower point potential is the potential difference across this, or else lower point potential minus the higher point potential is the negative of potential difference across this. So I hope this is clear to you all. So this is the basic prerequisite we have. Now if you consider this as 0 volt, what is the potential at this point? So directly you can write 10 volt right now. Why? Because x minus 0 must be equal to 10. So that x we have is 10 volt. Okay, now this point potential we don't know, so I'll consider this as x volt. So this point potential is 0. So now we can find what is called as the current in this by using the Kirchhoff's current law. And by Kirchhoff's current law, right, at node sum of incoming current must be equal to outgoing current. Over here I am considering the current is flowing through this, or else you can consider x as higher potential, and that current will flow always from higher potential to lower potential. So this is I1, I2 and I3 we have. So we can consider I1 plus I2 plus I3 is equal to 0. So what is I1 now? X minus 10 divided by 2 by Ohm's law. Potential difference divided by the resistance is the current. So I1 we have is potential difference is X minus 10 divided by the resistance we have is 2. Plus what is I2 over here? I2 is X minus 0 divided by 2. Plus what is I3? X minus this total 0 divided by 6 is equal to 0. Now multiply by 6. So you will get 3x minus 30 plus 3x plus x is equal to 0. So you will get this as 7x is equal to 30. So x is equal to 30 divided by 7 volts. So this is the potential at point A. Right now, potential at point A, that is x potential we have is 30 by 7 volts. Now we want what is the current flowing through this. So current through 3 ohm resistance is I is equal to the potential difference x minus 0 divided by 6, which is equal to 30 by 7 divided by 6, which is equal to 5 by 7 ampere है ना. So over here the potential at this point is x, that is equal to 30 by 7. This is the 3 ohm resistance, this is the 3 ohm resistance, this is the ground given, that is 0 volts. So this is 3 ohm, this is 3 ohm, this is 30 by 7 volts. So potential difference across this is 30 by 7 minus 0 divided by total resistance is 6. So this is the current we have, and that is 5 by 7 ampere, right? So I hope this is clear. Once we know the potential at this point, you can calculate the current through 2 ohm, current through 2 ohm, current through this 3 ohm, है ना? So I hope this is clear. I1 you can calculate, put x is equal to 30 by 7 over here, you will get I1. Put x is equal to 30 by 7 over here, you will get I2. Put I3, that is x is equal to 30 by 7 over here, you will get I3. So if you know I1, I2, I3, you can find out the potential difference across 2, potential difference across 2, potential difference across this 3 and that 3. Okay, so I hope this is clear to you all. Now the next question. In this question, we have to find the current through the 5 ohm resistance. Now this current we want, right? What is the current through this 5 ohm resistance? Now I told you can consider at any point, at any random point is 0 volt, right? Now or potential, any potential. Why to consider 0? You can consider 10 volt, you can consider 20 volt, right? And accordingly the other point potential will change. So I will consider ground at this point. Ground means what? 0 volt. So over here short circuit, everywhere it is short circuit, everywhere as you can see it is short circuit. Over here also this is 0 volt, over here also 0 volt, here over here also 0 volt. Okay, so if this is 0 volt, this is 10 volt. If this is 0 volt, this is 10 volt. Indicates at this point it is 10 volt only, because this is 10 10 10 short circuit, isn't it? 10 10 10 everywhere it is 10. Okay, so I hope this is clear. By mistake don't do this, that is this 10 volt and this 10 volt, right? This 10 volt and this 10 volt, addition of this, and here it is 20 volt. No, that is not the case over here. Okay, it is the 10 volt potential at this point, at the terminal, at the node, we can say. It is only the 10 volt. It is not the addition of 10 and 10. Why I will tell? This 10 volt and this 10 volt are in parallel, right? As they are in parallel, the potential difference in parallel will remain same. Okay, now as potential difference in parallel remains same, the potential at this point will be equal to the potential at this point, right? Now, so 10 volt potential, this is 0 volt potential. So what is the current through this 5 ohm resistance? It is the potential difference divided by the resistance, which is equal to, what is the potential difference across this 10 minus 0 divided by, what is the resistance? 5. And if you just solve this, you will get 10 divided by 5, and that is equal to 2 ampere. 2 ampere. So I hope this is clear. I hope this is clear. That is the option A we have. Next question. In the shown network, current through 20 ohm resistor equals to. Current through 20 ohm resistor is equal to. That is what we have to find out. So 20 ohm resistance is this one. So let us consider the current through this 20 ohm resistance is I. Okay, I, and I told you can consider at any point the potential as 0. So now I'll consider at this point 0 potential, right? 0 volt. No need to consider at this point. You can consider at this point also, at this point also. That is totally your choice. Accordingly, the potential will change, right? So I'll solve by using this method, and in the next I'll take at this point, right? In the same question, but I'll take the potential at this point and I'll prove that you will get the same answer. Okay, so this is the 0 volt. This is the 0 volt. What is the potential at this point? Minus 10 volt. What is the potential at this point? Plus 20 volt. Right now, minus 0 minus of minus 10 will be 10 volt. 20 minus 0 will be the 20 volt. Right now, so this is minus 10. This is minus 10. This is also minus 10 volt. Likewise, this is 20 volt. So what is the potential difference across this? As you can see, potential difference across this is 20 minus of minus 10 will be the 30, right? So current we have is potential difference across 20 ohm divided by the resistance, which is equal to, what is the potential difference across 20 ohm? 20 minus of minus 10. So now some of you might say, why you considered current in this direction? Why not in this direction, right? Initially, you can consider initially in any direction, right? That is totally your choice. Okay, but if you just take the current in this direction, you have to consider minus 10 is the higher potential, 20 is the lower potential. Though we can see that 20 is higher and minus 10 is lower, but according to your sign convention or according to your convention, current you took is in this direction, from left towards right. So what you have to consider is minus 10 minus 20 divided by 20 minus 30 divided by 20 is your answer, right? But that minus sign indicates whatever direction you took is wrong. You have to consider in the opposite direction. So I considered initially from right towards left. That is correct. Okay. So why? Because 20 minus of minus 10 divided by 20, you will get 30 divided by 20. So which is equal to 3 divided by 2 ampere, and this is positive. As it is positive indicates whatever direction I chose is correct. If answer would have come out to be minus sign, with minus sign, then you have to consider that negative sign means whatever direction you took is wrong. You have to just consider the opposite direction. So over here 3 by 2 is the correct answer. Okay, so I hope this is clear to you all. Okay, and yes, if you find any difficulty in any question, just comment in the comment box. I'll try to give reply right then and there only. Okay, so next problem, fourth one. As you can see here, a switch S is closed in the circuit shown in the figure. Right now, this switch S is closed. Current through point A is, so we want what is the current flowing through this point A. So now if switch is closed, potential at this point is 0 volt. If the potential at this point is 0 volt, you can consider potential at this point is V volt. That is what given. So we have to find what is this V. Okay, so let us consider V is higher potential. This is I1, this is I2, this is I3. So by Kirchhoff's current law, current I1 plus I2 plus I3 is equal to what? 0. So what is I1? V minus 20 divided by 2 plus what is I2? I2 is V minus 5 divided by 4 plus what is I3 over here? I3 is V minus 0 divided by 2 is equal to 0. So now multiply by what is called as the 4, you will get, this is V minus 20 times 2 plus V minus 5 plus 2V is equal to 0. So you will get 2v minus 40 plus v minus 5 plus 2v is equal to 0. So this 2v, v and 2v, it will become 5v is equal to minus 45. So v is equal to, sorry, plus 45, v is equal to 9 volts. Once we get this 9 volt as a v, right? So what is I1 now? I1 we have is v minus 20 divided by 2. So you will get this as 9 minus 20 by 2, which is minus 11 by 2. What is I2 then? I2 we have is v minus 5 divided by 2, which is 9 minus 5 divided by 2, which is 4 divided by 2, and that is 2 ampere. And lastly, I3 we have, I3 is equal to v divided by 2, which is 9 divided by 2, that is 4.5 ampere. So as you can see over here, once you know the concept, you can solve any type of questions with ease, right? Over here we want what is the current through point A, that is through this. I3 we want, and I3 we have calculated, that is 4.5 ampere. So option A is the correct option over here. Next question. What current is flowing through 2 ohm resistance? Now this 2 ohm resistance is given. What is the current flowing through this 2 ohm resistance? That is what we have to calculate. Sure. So over here 2 ampere is given. This is 2 ampere. So what is the potential difference across this 8 ohm? So I'll just draw the circuit. This is 2 ohm. This is 4 ohm. This is 8 ohm. This is 2 ampere. So if you just multiply this 2 with this 8, you will get 16 volt. This 16 volt, right? This 16 volt is the potential difference across this 8 ohm, and we know that potential difference in parallel remains same. So if this is 16 volt, what is the potential difference across this? This must be 16 volt. What is the current flowing through this then? Potential difference divided by resistance will be the current, that is 4 ampere. So 4 ampere. If this is 4, this is 2, what is the Kirchhoff's current law? Sum of incoming current must be equal to the outgoing current. This must be 6 ampere then. So if this is 6 ampere, what is the potential difference across this? 6 into 2, 12 volts, right? But they want only the current flowing through this 2 ohm. So it is very simple, it is 6 ampere. See, if you know the Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, by using these 3 laws, we can actually simplify any type of electrical circuit with ease. Okay. Chalo, next. If 3 ampere of current is flowing between P and Q in the circuit, then potential difference between P and Q is, we want what is the potential difference between this P and Q point. Okay. So I'll just draw this diagram. This is 2 volt. This is Q. This is P. This is 3 ampere. This is 2 volt and 2 ohm. And this is 4 ohm. And the current is 3 ampere given. So everything done? Yes. So we want what is the potential difference between P and Q. So you can start from point P and you can end at point Q right now. So we have Vp, potential difference, potential at point P. Let us consider it is Vp, and the potential at Q is Vq. So potential difference, that is Vp minus Vq we want. So Vp is equal to, now this is plus, this is minus. We are going from positive towards negative, that means dropping the potential. So whenever dropping, you have to consider negative sign, and whenever gaining, you have to consider positive sign. Dropping indicates what? Whenever you go from positive, that is higher, to negative, that is lower, right? Positive, that is higher, to the negative, that is lower, then that is dropping. And whenever you go from negative towards the positive, that is gaining the potential. Okay now. So over here Vp, dropping the potential, so minus Vp is equal to, sorry, it's not is equal to, what you have to write is Vp, just a minute. So over here, this is Vp, right? Then dropping the potential, so minus 2 volt. Then it is plus to minus. Here also 2 ohm resistance is there, that is plus to minus, dropping the potential. So it is minus 2 into 3 6 minus 4 into 3 12 is equal to Vq, potential at this point. Okay, now so whatever this potential drops in the internal resistance is equal to the potential at this point. So over here Vp minus Vq we want, which is equal to, this is 12 plus 8, which is 20 volts. Okay, now so I hope this is clear. In the resistance always remember current flows from higher to lower, right, in the resistance. And for a battery always remember higher terminal, that is longer terminal, is positive, and the smaller terminal is always the negative, right? So if you go from positive towards negative, it is dropping, and if you go from negative towards the positive, it is gaining. And in the resistance, according to current, you have to write the current always flows from higher to lower. So I hope this is clear now. So sixth one done. Now next, potential difference Vc minus Vb in the circuit is, okay, so we want what is the potential difference between the point Vb and Vc. So Vc minus Vb we want. So for that we need potential difference across this 1 ohm, 12 volt we know, 2 ohm, 3 volt, 4 ohm, 2 ampere. Okay, so over here I'll just draw the upper circuit now, because we want only the upper circuit. Current and the potential difference across that. Okay, so over here this is 1 ohm, this is 5 ampere. So what is the potential difference across this? Current always flows from higher to lower, that's why plus minus. Okay, 5 into 1, this is 5 volt, this is minus, this is plus. Always remember bigger terminal positive, smaller terminal negative. This is a resistance of 2 ohm, this is 12 volt. Done. This potential we know now. This 2 ohms, what is the current? This is 3, this is 5, right? This is 5 ampere, this is 3 ampere. Sum of incoming current must be outgoing current, that is 8 ampere. So over here we have 8 ampere, right? Over here we have 8 ampere. So 8 into 2, 16 volts. This is positive, this is negative, this is 3 volt. Then we have 4 ohm, and in this current is given 2 ampere. Current always flows from higher to lower, so 2 into 4, 8 volts. This will be point C, this will be point B. We want Vc minus Vb, so start from point C and go towards point B. So Vc, then dropping the potential as we are going from positive to negative, so minus 5, then negative to positive plus 12 by gaining the potential, then positive to negative dropping the potential, so minus 16, then positive to negative dropping the potential, so minus 3, then positive to negative dropping the potential, so minus 8 is equal to the potential at B right now. So this potential drops gains is the equal to potential at this point. So now just calculate, we'll get Vc minus Vb is equal to, we have this 12 minus 5 minus 16 21 3 24 2 8 32 minus 32. So if you just solve this, you will get this as this is minus plus, this is minus. Why? Because we are taking this side, no, this side, Vb this side, this total term this side. So 32 minus 12, it will become 20 volts. I hope this is clear now. So it is very much understandable now, isn't it? Right. So if you start from point C, whatever drops, gains, drops, is equal to the potential at this point, है ना? So if you follow this method, you can calculate potential difference across any electrical circuit with ease. Chalo, next problem it is given. In the figure given below, the potential difference between point M and N is okay. So this is 1 ampere given. This is 1 ohm. This is the single circuit we have. This is 1 ampere. So everywhere it is 1 ampere, and internal resistance is also given. So I'll just draw the circuit once. So over here, this is the 8 volt. Then a resistance we have 1 ohm, and this resistance, external resistance 1 ohm. Again this is 10 volt, internal resistance 1 ohm, and the external resistance 2 ohm. This is 12 volt, internal resistance 1 ohm, external resistance 2 ohm. Then this is 14 volt, internal resistance 1 ohm, external resistance 1 ohm, and this is point N. So the current is flowing like this. We have 1 ampere. So this is point M, this is point N. So positive, negative, current always flows from higher potential to lower, so it will become 1 into 1, 1 volt, 1 into 1, 1 volt. So this is positive, negative, higher to lower, this is 1 volt, 2 volt. This is negative, positive, this is positive, negative, by higher to lower, 1 volt, positive, negative, 2 volts. Then this is positive, this is negative, this is positive, negative, positive, negative. So this is 1 volt and this is 1 volt. So start from point M and end at point N. So Vm, then dropping the potential, so minus 8, gaining the potential, so plus 1, dropping the potential, so minus 10, gaining the potential, so plus 1, plus 2, dropping the potential, so minus 12, gaining the potential, so minus 1, gaining the potential, so plus 1, plus 2, plus 14, gaining the potential, then gaining 1 volt, and the 1 volt right now is equal to Vn. Chalo, so Vm, this is minus 8, minus 10, 18, minus 20, minus 12, that is 30, right? This is 30, so minus 30, 1, 2, 3, 5, 6, 8, 9, 10, and 14 is 24. Plus 24 is equal to Vn, and if you just solve this, you will get Vm minus Vn is equal to 6 volt. So as you can see, answer for this question is option C. So you can solve this type of questions by following the two steps only. One is mark all the polarities, right? Mark all the polarities and go from point A to point B, right? And apply Ohm's law. Obviously you have to apply the Ohm's law at each and every element. Chalo, next. When a voltmeter is connected across a 400 ohm resistance, this is the voltmeter connected across this 400 ohm resistance, it reads 30 volt. So this voltmeter reads 30 volt. When it is connected with a 300 ohm resistance, it will read, okay, so when voltmeter is connected, it will read 30 volt. Now if it is connected with 300 ohm resistance, it will read. Chalo. So firstly, we'll calculate what is the resistance of a voltmeter, internal resistance of a voltmeter. Okay, So see here, as this is 30 volt, what is the current flowing through this? Current flowing through this is 30 volt divided by the resistance. So we have current is equal to 330 divided by 400, which is 3 divided by 40 ampere. 3 divided by 40 ampere. Okay, so current in this is 3 divided by 40 ampere. Right then, so this 30 volt will exactly apply across this, right? This is 30 volt. And what is the potential difference across this? If this is 30 volt, what is the potential difference? It must be 30 volt. And what is the current then? So it is 30 divided by 300. It will become 1 divided by 10 ampere. So 1 divided by 10 ampere is incoming. 30 by 40 is outgoing. What is the current in this? It must be 1 divided by 40 ampere, isn't it? 1 divided by 40 plus 3 divided by 40 is 4 divided by 40, which is equal to 1 by 10 ampere. So once we know the voltage and the current, we can find out the resistance of voltmeter, and that is equal to, resistance of voltmeter is V divided by I. So V is 30 divided by I is 1 by 40, so which is equal to 1200 ohm. 1200 ohm is the resistance of voltmeter. Now if you connect the same voltmeter across the 300 ohm resistance, right, 300 ohm resistance, it will read, let's see, this is 60 volts, so this is 1200 ohm, this is what is called as 300 ohm. So current I is supposed to be, so we have equivalent resistance. Firstly we'll calculate. It is 300 into 1200 divided by 1500. So this 0, this 0, this 0, this 0 get cancelled. 3 5s are, 3 4s are, 5 6s are. So it is 240 ohm we have, right? 240 ohm we have. Once we got this R equivalent, so this 240 ohm plus the 400 ohm will give you the total resistance of this, and that total resistance we have is 640 ohm. Once we know the total resistance, now we can calculate total current, which is 60 divided by 640. So 0 0 get cancelled. We'll have 2 3s are divided by 2 3s are 3 2 2s are 4. So you will get current as 3 by 32 ampere. Now this 3 by 32 ampere will pass through this and that voltmeter will read the same current, right, the same voltage then. So voltage across this 300 ohm is current through 300 ohm into 300 ohm. So how to calculate current through 300 ohm now? It is the total current we have 3 by 32 into opposite resistance we have 1200 divided by the total resistance we have 1500. So 0 0 0 0 get cancelled. We'll have then, this is 3 by 32 into 12 by 15. So 3 5s are we have, right, 3 5s are 15. So this is 6 divided by 16 into 5, so which is equal to, this is 3 divided by 40 ampere. 3 divided by 40, not 40, yes, it is 40 only, 3 by 40 ampere. So in this 3 by 40 ampere indicates what is the voltage. So 0 0 get cancelled. We have, this is 45 divided by 2, which is equal to 22.5 volts. 22.5 volts. So as you can see, this is given in option B. This is given in option B. So this is how you have to solve. So firstly what you have to do is, firstly calculate the internal resistance of this voltmeter. Once we know the internal resistance, connect that voltmeter to any resistance, calculate the total resistance of the circuit. Once we know the total resistance, find out the total current. Once we calculate the total current, find out the current through that particular element, and you can find easily what is the voltage across that element by that will be read by the voltmeter. Okay, so in this 10th question it is given, figure shows a circuit with two cells X and Y in opposition to each other. Cell X has EMF 6 volt and the internal resistance given. Cell Y has an EMF 4 volt and internal resistance given. What is the voltage between the terminals A and B? So we want what is the voltage across this. So I'll just draw the circuit. So it will be X, that indicates 6 volts, and this will be internal resistance 2 ohm. Then we have, this is the 4 volt and internal resistance, 4 volt and internal resistance 8 ohm. We want what is the potential at this point, difference between this point, right? Voltage between terminals A and B. VA minus VP we want basically. So firstly, we'll start from point A and we'll go to the point B. So for that we need what is called as the current. Now how to find the current? Let us consider the current in the circuit is I. Right, current in the circuit is I. So start from point A and come back to the point A only. So as you can see, this is positive, this is negative, and the same circuit is there, so current will be the same. So this is positive, this is negative, this is positive, this is negative, this is negative, this is positive. So I'll start from point A, yes, dropping minus 4, then dropping minus 8 into I, then dropping minus 2 into I is equal to, sorry, then plus 6 is equal to 0. Now let's start with VA minus 4 minus 8i minus 2i plus 6 is equal to VA indicates is equal to 0 only, right? Potential difference at the same point will be the 0. So we have 10i is equal to, this is 6 minus 4 plus 2, so it will be 2. So I is equal to, we have 0.2 ampere. Once we know the current, now find out the potential difference across this A and B. It will be VA. You can go downward or the upward. You can go like this or else like this. That is totally your choice. So I'm going to the from the below side. It will be minus 4, then minus 8 into 0.2 is equal to VB. So VA minus VB we have is 4 plus, this is 1.6, which is equal to 5.6 volts. That is given in option B. That is given in option B. So I hope this is clear. Or else you can do it directly also. So see how. I'll just take this as a circuit. You can do this directly also. This is given what is called as 6 volt. This is given 4 volt, 2 ohm and 8 ohm. Okay. And this is A point and this is B point. So see, this positive terminal is connected to the positive terminal of a battery. That indicates they are connected in a reverse bias condition. So we can say that 6 minus 4, it will become 2 volt. So what is the potential difference in the circuit? 2 volt. What is the resistance in the circuit? 10. So you will get current in the circuit is 0.2 ampere. Once we know the current, you can find out easily now what is the potential difference across V and B. So it will be like this we have. So this is positive, this is negative, this is positive, this is negative. So I'll go from up to now like this. So firstly VA, then dropping minus 6, then gaining 2 into I 0.2 is equal to VB. So we have VA minus VB as 6 minus 0.4, which is 5.6 volts. So as you can see, so this is the second method we can say. This is the first method we can say. So I hope all these questions are clear to you. If you like this video, do subscribe to my channel and do comment on this video. Thank you so much.